All right, section 4.4 is, we're going to split it up over 2 days. Just so that you guys have this in the back of your minds, like I mentioned to you already, we're going to split the chapter in half. This is the last chapter or section that we're going to have before the first test. So we're going to do this Monday, today and Monday, and then we'll get a review assignment Tuesday. We'll go through it Wednesday, test Thursday, then you're off Friday. So anyway, so just so that you are kind of up to date with that, here's what you're going to see on this first problems. You're going to see something like this. It says 5z to the fourth plus 30z to the third plus 45z squared. And what it's going to ask you to do for that is it's going to say factor completely. So for today, we're going to just focus on factoring. I want you to notice one thing with this. Is there an equal sign? No. You are not solving for z or x or whatever letter it is. You're just factoring. So when you factor, the first thing you should always look at doing is there anything you can take out of all three terms to begin with? A 5 for sure, and how many z's? 2. I can take out z squared. So if I take out 5z squared, what times 5z squared would give me 5z to the fourth? Just z squared, because I've already taken the 5 out. What's 30, or what times 5 gives me 30? 6. And if I need 3 z's and I have 2 z's already, how many would I need more? 1. What times 5 gives me 45? 9 times. And if I already have z squared and I need z squared, do I need any more z's? No. Nope. So therefore, that's factored so far. Is this factored completely? No. But you have taken something out. So just so that you are aware of it, if you can't go any further, that's as far as you could go if you can't do anything more. But when you have squared left over behind there like that, I would assume that you could probably go and put 2 groups down. Like so. What times what gives me z squared? Z and z. What times what gives me 9, but adds up to be 6? Plus 3 and plus 3. Is there any more I can factor? No. Now, this answer, I would accept it if you leave it like this. Or if you would write it as 5z squared, z plus 3 squared. That would be also acceptable for this answer. What do you think? Have you done this before? Oh yeah, you have. I know it's not everybody's favorite, but it's what this one's about. Okay, what about 3n to the 7th minus 75n to the 5th? Is there anything you can take out to begin with? A 3 and a n to the 5th. 3n to the 5th goes outside. Now, when you take something out, don't just throw it away. You just put it on the outside. Okay? So if I took a 3 and an n to the 5th out, what would I have left over? No. On the front part first. N squared. Then what? Plus or minus 25? Minus 25. And all the n's would be accounted for, right? Can that go further? Yeah. So 3n to the 5th was already done, so. What times what gives me n squared? N and n. What times what gives me negative 25, but adds up to be 0? 5 and negative 5. This cannot be written any way differently because of the fact that it's not the same group twice. What do you think? Not too bad? Okay. Now, the next thing that I'm going to give you is I'm going to give you a couple formulas. Normally with this stuff, I'm not that crazy on formulas, but there is 2 of them that you're going to need because of the fact that they show up, and if you don't know how to do them, you will be stuck. These are the 2 special types that we're going to look at with this one. What they are is the top one is known as the sum of perfect cubes. And the bottom one's going to be known as the difference of perfect cubes. Now, what they mean by perfect cubes is they mean this. It's going to be numbers like 1, 8, 27, 64, 100, no, not 100, 1,000. Okay, they're going to be numbers like that. 150 or 125. What I did to get those numbers is I took 1 to the 3rd power, 2 to the 3rd power, 3 to the 3rd power, 4 to the 3rd power, 5 to the 3rd power, 10 to the 3rd power. They always show up. Those ones consistently show up in all books. 6 to the 3rds, 216. That's about as many as you're probably going to have to remember. 1 through 6 and then number 10. Those are usually the culprits. Okay? Here's how they work. For the sum of perfect cubes, when you factor it, it would be whatever A is plus whatever B is. And then in another set of parentheses, it would be A squared minus A times B plus B squared. Now, on the A squared minus AB plus B squared, that back group, that cannot go any further. You can't do anything else with it. This is as far as this factors. Okay? Same thing with the bottom one. A minus B, A squared plus AB plus B squared. What's the difference between the 2 formulas? The signs. Right. The sign switch. Notice how the front one was positive here because that was positive. And then the bottom one, this one's negative because that's negative. And then the sign switches in between or in front of the AB part. Okay? So here's how they're going to work. They're going to say something like x to the 3rd minus 125. Now, when I see that, something that triggers something in my brain is this. As soon as you see a group like this, the first thing you're going to ask yourself is, can you take anything out to begin with? For this problem, the answer is no. It does not share anything in common, so therefore you can't take anything out. The second thing that I notice is it says cube. So as soon as I see the cube in there, that means one of these formulas typically. Okay? So which formula would it model? The bottom one or the top one? The bottom one. Now what I need to know from you guys is what number multiplied by itself 3 times gives you 125? 5. So this is really like saying x to the 3rd minus 5 to the 3rd. So what letter is in the A position? X. What number is in the B position? 5. So all I'm going to do is take that formula I gave you, take the A out and put X in its place, take the B out and put 5 in its place. That's it. So the first one would be A minus B. What did we say A was? So X minus 5. Parentheses, parentheses. What is the A squared? X squared, good. Plus, what is A times B? 5x or x5. Typically we write it as 5x though, right? So 5x. And then the back group, what's the B squared? 5 squared, which is 25. And you're done. Yep. You could, but you might as well just do it. What do you think? Yeah, when it has that part for factoring. Let me give you an adding one. 8x to the third plus 6, let's not do that. Let's go plus 27. Okay, first thing I'm going to look at on that one is there anything you can take out of all two terms? No. But I've got an 8 in the front with an x cubed. The x cubed is the part that is supposed to help you trigger that, hey, this is probably a formula. What number cubed is 8? 2. 2 times 2 is 4, times 2 is 8. So this is really like saying 2 cubed, x cubed. And what number cubed is 27? 3. Now, that front group looks kind of goofy, but if you look back at some of your former stuff with exponents, it could also be written like this. Okay? If you look at something like this, when it had a product like that, and you had a power to a product meaning it went to each piece, which is exactly what it was showing here. So what I was trying to do by showing you that is, what's in the A position for this problem? What's in the A? 2x. Okay, 2x is in the A part. All right, there's more than one piece here. Rather than the first one where I just gave you one thing for the A, this has 2 pieces. If it has a number and a letter with it, you'll have 2 pieces for the A rather than just the one. So, if you go with the formula, what's A plus B? What's in the A position? 2x plus 3. Then you square it. What's 2x squared? Be careful. What, Hunter? 4x squared. Okay, why and how did you get 4x? Because remember, it's like saying 2x times 2x. 2 times 2 is 4. X times x is x squared. Minus sign. Now you take A times B. What's 2x times 3? 6x. Plus, what's B squared? What's 3 squared? 9 times. And you're done. That's honestly about as hard as they get. Okay, and the reason why I say that is because that's one that has 2 pieces with it on the A. Usually they don't have anything else like that, but just so that you are aware of it, that's about as hard as they get for those. How are you guys with the formulas? Okay. The next type of factoring that we're going to talk about is this type. First thing I always want you to do, can you take anything out to begin with? No, because the 20 doesn't have a Z. All right? So it has to be for all of them on the first part. Now, the thing that I wanted you to hear is the fact that you said no, but how many terms are there? 4. There's 4 terms, right? Whenever you have 4 terms, if you can't take anything out to begin with, then you're going to do a technique called grouping. You're going to look at just these 2 and then just these 2. Just with the front 2, what can you take out of z cubed plus 5z squared? Good. So if I take z squared out, what do I have left? Good. Now, looking at the back group, is there anything you can take out of negative 4z minus 20? Negative 4. And what would I get left behind then? Z plus 5. Because if you divided a negative by a negative, you would get a positive. Good. Now, when you do this the correct way, or if it does work, that is, did you notice how both of these were the same? That's a good thing. When you're trying to factor by grouping, that's what should happen. If it doesn't happen, it doesn't work. Or you messed up. Some people, when I give them that problem for the first time, they just say take out a positive 4, and then I have a negative z minus 5. They're not the same then unless I take a negative 1 out. So at this point right now, you guys did great. Now, this is still one group and this is still one group. What do they share in common? What was in the parentheses, right? Z plus 5. In another set of parentheses, if I take them out, what's left over? Z squared minus 4. Can z squared minus 4 go further? Yeah. What times what gives me z squared? Z and z. What times what gives me negative 4, but adds up to be 0? Negative 2 and positive 2. And I factored completely. Okay? Again, when you have 4 terms, but the first thing you should always ask yourself for all these problems is, can you take anything out to begin with? Second thing that I would look at is, and if I can't, hey, do I have 4 terms? If I do, group it. If it's got an x to the third as the highest one and there's only 2 terms, it's probably one of those factoring formulas. Okay? Bless you. Do you want me to do another grouping one?
No.
Okay. All right, this is about the last thing that you guys are going to see is something that looks like this. Can you take anything out? Is there anything that 16 and 81 share in common? Not 81. Is there anything? Now, I didn't give you a formula for x to the 4th, did I? Because there isn't one. So what you do on this is you treat it like a quadratic. Okay, so what I'm going to set up is I'm going to set up something like this. What times what gives me 16? 2 and 4, or no, 2 and 8 I mean, 4 and 4. Let's try the 4 and 4 and see what happens. So 4x squared and 4x squared. What times what gives me negative 81 but adds up to be nothing? Negative 9 and positive 9. What do you guys think so far? Pretty good? Did it work? Absolutely. Are you done? No. Whenever you factor it like this, if you still have quadratics left in there, remember, highest exponents 2, always assume you can go further. This one cannot. Because what times what is going to give you 9, but add up to be 0? It ain't going to happen. Unless we have i's, which we're not going to do i's when it comes to factoring. But what times what gives me 4x squared? 2x and 2x, I heard Sierra mumble. And then what times what gives me negative 9, but adds up to be nothing? 3 and negative 3, whichever order you put them in. And that's as far as it can go. So what I did is I treated it like a quadratic in order to do that. What do you think? Okay, now I know you guys have done this before, maybe not as hard in Algebra 1 with some of these problems, but the factoring process didn't change. All that's the same. What do you guys think? Are you guys okay? All right. So starting on page 184. And we got 6 to 38 evens.